Now I want to look at three examples that are word problems that can be done using quadratic equations. Now they are going to resemble some word problems you've done in the past, but one part of them is going to be slightly different, and that difference is what makes them quadratics instead of linear. First of all, we've done problems before with integer type problems. For example, we've looked at problems where the sum of two integers is equal to some known value. Those problems always turn out to be linear. Now we're going to look at some quadratics. So let's say we have two integers and their product is 64. So we have a product equaling 64. Now you're told that one of the two integers is 4 times the other. So if we were going to pick variables, we will let the first integer be represented by x, and the second one would be represented by 4x, since one is 4 times the other. Now the equation is going to be 4x times x equals 64. We'll multiply. We'll have 4x squared equaling 64. And our strategy for solving quadratics is to set everything equal to 0 first. So I'll subtract over the 64. And I'll have a 4x squared minus 64 equals 0. Once everything's set equal to 0, we start factoring. 4 is a common factor here. It's the greatest common factor. So I will pull it out. I'll have an x squared minus 16. And continuing the factoring, I have a difference of squares here, so I'll have a 4. Difference of squares breaks down into two binomials with an x and an x, a plus and a minus, and we'll factor the 16 as a 4 times 4. Now we will set each factor equal to 0, solve, and we may think we have the two solutions here, but actually what we have is the first half of one solution. In the negative 4 we have this, and in the positive 4 we have the same thing. So since our first number is x, that means our first solution is negative 4, comma, and 4 times that would be negative 16. So multiplying by 4, as it indicated we needed to do up here, we have one complete solution, an ordered pair, or a pair, not necessarily ordered. Our other solution would be a 4, comma, and again 4 times that would be 16. So here we have two solutions to this one problem, a number and 4 times the number, such that their product gives you 64. Now other types of problems we've done before in our examples have been consecutive integer problems, consecutive even integer problems, and consecutive odd integer problems. Now if we're told that we have two consecutive positive even integers, then the first of those two we'll call x, and the second one we'll call x plus 2. And again, that's a labeling system that we've used plenty of times before. Now we are told that their product, which means we need to multiply them, their product is 48. So again, we set up a multiplication problem. We multiply it out. Oops, not plus, but equals 48. Now I will subtract the 48 over, and I'll try and factor. Since there's no GCF, I go straight to two binomials. Have an x and an x, a plus and a minus, and to get a 48, it's going to be a plus 8 times a minus 6, and that, if you check it, will give the 2x in the middle. And when we start solving, you may think we have two solutions here, or the beginning of two solutions. But as we solve, we note that one of our answers is negative, and the problem specifically stated positive even integers, so the negative 8 can't be used. So since our first number is 6, and that's the x plus 2 will be 8, and this time we only have a unique solution. The 6 and the 8 are the positive, even, consecutive integers that multiply to give you 48. Now the last example is going to be one of a geometric nature. We're told that we have a rectangle, and whoops, that's not a very good rectangle. Our rectangle has an area equaling 84 square inches. We're also told that the length is 2 inches less than twice the width. And we're asked to find both the length and the width. Now remember, for a rectangle, your area is length times width. So we set it up as length times width, set it equal to the 84, and start multiplying. We'll have a 2w squared minus 2w equaling 84. Subtract the 84 over. Now we need to look for GCF, and I believe it's 2. So the 2 comes out, and now we can continue factoring the trinomial into two binomials. W squared factors is w and w. Plus and minus gives you a minus, and I believe a plus 6 and a minus 7 gives us the correct factorization. So again, solving one at a time, we see we have, again, potentially two answers. But remember, since we're talking about lengths and widths here, negative answer can't be allowed. So obviously our width is the 7, and 2 times the 7 minus 2 is a 12. So we have a 12 by 7 rectangle, and that gives us the area we want with the restrictions on the sides that we were looking for.